ladies and gentlemen, here we go. So, we set people's speed, add to a person a new parameter. And this parameter will be called preference for convenience store meals. Okay? Okay, that indicates preference for convenience store meals. Okay, now, this is going to be a double precision quantity. And now, pursuant to Nick's question, we're going to add two variables into the model. And mark my words, preference for convenience store meals will be a characteristic of that person. That is just, we're going to give it as an assumption. These two variables will, by contrast, be counts. Count convenience store meals remaining. And this will be, what do you think it is? If it's a count, it's probably a what? Indeed, an integer. Okay? And next, I'd like to add in a count supermarket meals remaining. Count supermarket meals remaining. And once again, what sort of type will it be? Okay. Now, for supermarket meals, I'd like to make its initial count be 9. And for convenience store meals, I'd like to make its initial meal count be 3. Okay? 3. Are we okay with that? Okay, ladies and gentlemen, I would like now to add in an eat meal event. Eat meal event. Now notice what I'm doing, ladies and gentlemen. Before, when we added events, I believe they were always to main. We had an event for immigration. We might have had an event to have some initial intervention applied. In another case, you might have an event for reporting, which updates a histogram or some other data. And in general, you need in AnyLogic to be aware that you need to break out of the thinking that certain things only live in main or only live in person. For example, a state chart. All the state charts we've seen thus far have lived in person, lived in an agent. But there's no reason you couldn't have a state chart in main. For example, to represent the seasons, fall, winter, spring, summer. You might have a state chart that represents that. Or to represent, for that matter, weekends, weekdays, or something like that. Similarly, events can live in persons. You can have a person have an event which goes off periodically and triggers some action. Okay? Okay, so, ladies and gentlemen, we'd like to set the rate of this event to be 3 per day. Are we okay with that? Are we okay? 3 per day? Yeah? Okay, great. Okay, now, ladies and gentlemen, now we're going to go off in a very different direction. We're going to add in to this model something you've never seen before. It's over from the palette, and it's in an area of the palette that's new to you, and it's called the action chart area. Do you see that? Action chart? Can we go click on that? Okay. Okay. So for the action chart, ladies and gentlemen, we're going to be using some of the constructs that we see here on the left-hand side. An action chart is an intensely visual way of depicting logic within your model. And it is a way that can be used to encode the same sort of logic for which we would normally write a function or write some code, but to do so in a way that's communicates more readily. Okay? So, ladies and gentlemen, I would like you to drag in an action chart to your model, and this action chart is going to be called a eat meal action chart. Okay? Okay. 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 So this eat meal action chart is going to be associated with a variety of decision rules. It's going to encode a decision rule, and that decision rule is going to have a number of sort of considerations that are involved in it. So we're going to build this up piece by piece by piece in a way that reflects the kind of logic of the different cases. And what it's going to need to take into account is the number of meals remaining, the amount of preference for one sort of meal over another. And it's going to need to take into account the fact that at a certain point we may have no meals in the larder, in which case we're going to have to procure a meal from the supermarket or from a grocery store. Okay, so ladies and gentlemen, I would like you first to go put in place a decision rule, or decision here. So this is going to be called eat meal action chart, okay? Here, eat meal. Are we okay with that? Okay, eat meal. Now, you'll notice that by putting eat meal, there's a set of choices, but it kind of puts this default block here, which you can go on and describe some logic. I am going to put a decision there. Now watch how I do this. I drag this over and, I need to connect it. Boom. So let me do that again because I flubbed it the first time. Ready? Watch this. Drag it over. Do you see how it changes that to green? So I want it to be green. If I drop it and it's not green, it won't be good. Green is good. Okay? Green is the color. Okay? And you drag that. Okay. So, ladies and gentlemen, what we're going to put in place here is some logic and, in fact, a label. Okay? And the label here, ladies and gentlemen, is going to be the simple one. It's going to, for the label, Kurt may exhibit displeasure, but it's going to say, do we have both types of meals to choose from? That's the label here. And you'll notice that when I first type that in, there's not space enough to show it. So what I'm going to do is I'm going to drag it like this so that it's big. How did I do that? First of all, I selected that thing and I typed into the label, do we have both types of meals to choose from? And then I clicked here and I dragged and just to give it enough space. Are we okay with that? Okay. Ladies and gentlemen, I admire your resilience. Okay, now we're going to need to handle a case where this is true and where it's false. But we need to make it clear what the actual rule is here. I mean, after all, we specified it in rough terms, but we have to express it computationally. In other words, what does this mean in clear terms? Well, maybe you could tell me. How would you, if you needed to ask the question, do we have both types of meals to choose from? And I were to note that the number of meals are given by these variables up here on the upper left. Could you tell me what that formula, what that expression, as we say, might involve to say, do we have both types of meals to choose from? That condition, if we wanted to have a condition that would encode we have both types of meals to choose from, how would it be? What would it involve in terms of these two things? Okay. Count convenience store meals remaining is what? What would it need to, if we have both types available to us, this must be, it's a count, so it has to be, suppose this is 0. Would that be true? So needs to be more than 0, right? And I'm going to write and. Now this is going to be a little bit of squeezing for you. It's going to be a bit of stretching. Ready? This should be and. You have to write and like that in Java. This means logically and. Count convenience store meals remaining and count supermarket meals remaining. What is this? What's the criteria for this? If we have both, this will be greater than 0 also, right? Right? Yeah. Does that make sense? Okay. It wouldn't be any easier if it were an R. Same basic logic, right? Okay. So this is the condition that is being checked by this. This is just unpacking this question into a computational way, right? But importantly, a stakeholder who's not interested in how the model's implemented could look at this and better understand what this means, right? Okay. And maybe you don't want to have to look at this stuff all the time. Maybe you just want to be able to glance at this and not have to do with the vagaries of how it's implemented. This is going to tell you what is being done. Logically, what's the condition mean? Okay, now we're going to have to handle both cases here. So if it's true, ladies and gentlemen, if that is true, then we're going to have one set of considerations. Otherwise, we're going to pursue one set of things, okay? Otherwise, another. Okay. So, ladies and gentlemen, I would like to go now to put in place a situation where we are going to handle the false case first, okay? And for the false case, we're going to put in place a further condition. You notice I'm dragging this in and I'm going to put it on here. Green is the color. I'm going to put it right over this thing, okay? Boom. Okay? And what we're going to what we're going to put there, ladies and gentlemen, is something that is going to ask a further condition, which is basically which type of meal do we have, okay? So this is going to say, the label for this is going to say, do we have only convenience store meals available? Because look, we know if this is false, we don't have both to choose from. We only have one. So we need to figure out which one we have. Okay? Probably we should label this decision only convenience store meals, or decision is only convenience store meals, or have only convenience store meals. That's nice. Meals. Okay, this isn't necessary to name it really nicely. It's just, if you see its name later, you'll know what it is. Oops, available. We okay with that? So I named it decision have only convenience store meals. Okay, and probably this one I should have named as well. You know, decision have both types of meals. So I just named these. That's not critical. You probably could get by without doing it, but I just named them. Okay, ladies and gentlemen. So if this is false, we're going to check. Okay, we know we don't have both types of meals. What type of meal do we have? We're going to first check, do we have a convenience store meal only? How are we going to operationalize that in terms of those variables? How would we check if we only have a convenience store meal available? What would the condition be? That's right. Count convenience store meals greater than 0, right? We know one of them has to be 0 if this was false. So we'll just check, do we have this? Now, if that's true, we're going to eat a convenience store meal. And ladies and gentlemen, so this is the count convenience store meals remaining. So that's the criteria for this to be true. We put as, do we have only those meals available? And that translates into that criteria. Are we ready for this? Who needs a bit more time? Yeah.
I just have a question with the,
Uh-huh.
yeah. So why here, for example, we don't have the semicolon in the condition?
Because this is actually computing, it's a great question, This is computing a value. This condition is going to be true or false. It's actually not doing, it's not saying like, change this or, make this happen, print this out, infect this person, connect these two people. Instead, it's just computing a value. It's either true or false. So we don't need a semicolon. Does that make sense? Yeah. Okay? Great question. I welcome those. Okay. Are we okay then with this? Okay. So if we do have convenience store meals available, let's drag in this code here. Ready? Boom. If we have convenience store meals available, what are we going to do? Well, we're going to give it a label. So, let's give it a name. It's going to be eat convenience store meal. Its label is going to be eat the convenience store meal. Remember, these labels are things that non-programmers can look at. It's things you will look at when you don't want to see all the details. You have lots of other things to work on in the model. You don't want to see all the details all the time. Okay. Eat the convenience store meal. Now, what are we going to do for that? Well, that, ladies and gentlemen, is going to be done by the following. The question is, how are we going to operationalize eat a convenience store meal? Well, there's two things, ladies and gentlemen, that's going to happen. Could anyone tell me one of the things that's going to happen? I'll give you a hint. It involves the count of the convenience store meals remaining. How is that going to be affected by eating it? Yeah, it needs to be made one less than its current value, right? Okay, so count convenience store meals remaining. Now, I'm going to write it in a certain way. And then I'm going to show you something that's an alternative way. But it's an alternative way you'll see so frequently that I think you got to know about it. It's a little bit puzzling, but it's another way of doing it. Okay, so ladies and gentlemen, what this is saying is, okay, if we eat a convenience store meal, we are going to decrement. We're going to decrease by 1 the number of convenience store meals remaining. We ate it, right? So it's not remaining. But when you see an expression like this, or actually a statement like this, where this is being updated, to parse it, wow, there's this big long thing here on the left and right, you got to kind of say, is this the same thing here as there? And sometimes it can take a while to kind of fully parse what's going on. Is it a different thing over here than it's there? You got to kind of read it. There's a much more abbreviated way we have to write this in Java. And may I show it to you? There's actually two ways. We can write it like this, which means this equals this minus 1. Okay? So in other words, it equals itself minus 1. We could write it like that. Even better, well, even more tersely, we can write minus minus. That just means it's decreased by 1. It's an integer and it's being decreased by 1. So we can do that in Java. And you'll see this around enough, it's good to know about it. So I'm going to leave that there, but you can choose which one you like. You could change it back to this if you'd like that, if you prefer. You could make it minus equals 1, or you could do it this way. It's up to you. It's up to your comfort. But I will just tell you, you'll see this a fair bit. And similarly, if we want to increase it by 1, we do plus plus. And if you've ever wondered why the language C++, you may have heard it's called C++, it's because of that. It's a reference to this, how that's one of the things you do in C a lot. So it's like 1 better than C. Okay. So count minus minus, that's one thing we have to do. The other thing we have to do is we have to make it so that our energy from food is reflective of a convenience store meal, right? So ladies and gentlemen, let's set energy from food equals 2.4. Okay. Well, we have a certain rate of energy intake from that food. Well, it's actually a certain amount, but over the span of a third of a day or what have you. Now, we're going to use this again. I don't like just hard coding it. So what am I going to do to give this a better name? I could introduce a what? A parameter. Where would I introduce that? It doesn't vary by person. Instead, it's just an assumption about the model as a whole. So where would I put it? In main. So let's go back to main at the cost of sort of a brief disjunction. We're going to go to main and we're going to add parameter. It's going to be called energy from convenience store meal. And it's going to be called energy from supermarket meal. Okay? Great. Okay. And ladies and gentlemen, I'd like to make energy from convenience store meals. The default value, if an experiment doesn't change it, is 2.4. And the energy from a convenience store meal is going to be a fraction of that. Okay, now my notes on this have just died. Okay, this is not good. Do you have it open right now? So I have it open elsewhere, so I'll just call it up. Okay, I have to kill it. This has happened 3 times now on this tablet. Okay, what's the other one? 1.5. Okay, 1.5. Thank you, Kurt. And I'll call it up here. 2.4. There we are. Yeah. Good. And 1.5. Yeah. Thank you. Okay. 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 Great. Okay. Excellent. Ladies and gentlemen. Oops. Pooh. There we go. Okay. So energy from convenience store meals is 2.4, the other is 1.5. Boom. Okay. Okay, so, ladies and gentlemen, let's go back now to person. Let's go back to this, eat convenience store meal. And now instead of saying 2.4, what do we want to set this to? Yeah, main dot, exactly, energy from convenience store meals. Good. Okay. Does that make sense to you? So we eat this food from the convenience store meals, and then the count decreases.
Is that bad?
Except, yeah, this is the old way of doing it, but yeah, that's right.
Would it help to have this?
No, I appreciate it. It's just this, for some reason, Google Docs conks out for some reason occasionally. I appreciate it, but I got it in the other window. Much appreciated, though, Kurt. Nice tablet. You'll want to help Tiffany when she comes back in, so she catches up on this. Yeah. Okay, ladies and gentlemen. So, next, ladies and gentlemen, we're going to handle another case. Okay, suppose we don't have convenience store meals available. Suppose that's not the case. What are the possibilities there? Do we definitely eat a grocery store meal then? Okay, we know we have both. We don't have both types. That's because this was false. We know we don't have a convenience store meal available. Can we just say, oh, we'll eat a grocery store meal? No, why? What might be the possibility? There might not be any meals. So we have to distinguish that case. So how are we going to do that with action charts? Can anyone tell me? What can we do? Yeah, another true false. Another decision here. So this one was called decision have only convenience store meals. Woo. Hey, oh gosh. Okay. Here, let me just get this. Okay. Here we go. Okay. Decision have only grocery store meals. Right? Super, thank you. Supermarket. Thank you, not grocery store. Thank you. Okay, the label here will be, do we have only grocery meals, supermarket meals available. Okay? Okay. Okay. Do we have only supermarket meals available? Okay, ladies and gentlemen, suppose we do. What do we do then? What do you think we'll do? Judging by the analogy with convenience store. We will eat it. Okay? Sorry?
I'll get a convenience store meal. My preference is to get convenience store.
Absolutely. You mean like even if there's a grocery store meal, they'll still go get it? Yeah, we could certainly do that. What we probably have then is if there's only a supermarket meal available, then you'd have a further decision, right? Like with a certain probability, I'll go, heck, let's do that. I mean, let's do that. Let's do it. So I just undid that. Let me show you how I just did undo. But another way I could do this is I could highlight it and do Control X. Boom. And it will go back. Okay? Okay, so let's do that. I love it, Nick. Love it. But, okay, let's get there. But let's ask, first we have to, do we have only grocery store supermarket meals available? What will the condition be for this? Yeah. Count supermarket meals remaining greater than 0. Right? Okay. If that's the case, then we're going to, ladies and gentlemen, if that's the case, then we will, per Nick's comments, we'll have a certain probability, this will be decision, how to put this,
Why?
sorry?
Is it by?
So, yeah, hankering for a convenience store meal, buy convenience store meal anyway. Anyway, something like that. This is for the case Nick brought up, that maybe if you really want, so this is the decision. So I'm going to say decision by convenience store meal anyway. So if someone has a really strong hankering for convenience store meals, maybe if they have one grocery store meal remaining, they'll still go to the convenience store.
Yeah.
Okay? Okay, ladies and gentlemen.
It is a bit adding complexity because if they prefer convenience store meals, then presumably they won't buy superstore meals or supermarket meals that often.
And so in other words, it would be rare case.
Yeah, it might not actually occur because you could put that reference within the purchasing as well.
Indeed, and we'll see that, yeah. Okay, so it's true. We'll represent this. Okay, so ladies and gentlemen, so here, this will be called, do we do we go to convenience, do we have such a strong preference that we go to, do we have go to,
Prefer?
do we so strongly prefer convenience store meals that we get one? Okay. Something like that. Okay, you could choose your own abbreviated way of saying that if you'd like. Okay, and what I'm going to say here is, this will be based on a preference. So, random true preference for convenience store meals. With that probability, we'll just go get one now. Now, we could use a different probability, but for now I'll get one. Okay. And if not, okay, so that we go get one. This should probably say go get one. Boom. Okay. Okay, so ladies and gentlemen, help me handle these cases. This is random true. Does anyone remember what this does? Random true? From before? What does random true do? Well, with a certain, it's a coin flip. With a certain probability, it returns true with a certain probability, false otherwise. It's a Bernoulli trial, for whom that's a familiar concept. For those for whom that's a familiar concept. In other words, with a certain probability, it'll be true, otherwise false. And this is the probability, the preference. Okay, it's a single Bernoulli trial. It's a coin flip. Okay, ladies and gentlemen. So that's random true. By the way, But it's false with a certain probability, so it's true with probability 1 minus that. That's another possibility. Okay, so ladies and gentlemen. So suppose we have a supermarket meal available. We don't so strongly prefer convenience store meals that we go get one. What are we going to do then? For this case here. Notice I'm dragging this in. What are we going to do? We have one convenience store meal available. We're not so hankering after a convenience store meal that we have to go get one.
Eat the supermarket.
We eat the supermarket meal. So the label here will be, eat the supermarket meal. And the code here will be eat supermarket meal case 1, I'll say. There's going to be other cases where we eat it. Okay, great. Eat the supermarket meal. There we go. Boom. Eat the supermarket meal. So how are we going to eat the supermarket meal? Well, just like the one we did before, right? What do we have to do? What are the two things we have to do? Remember we ate a convenience store meal before? What do we have to do?
Subtract the supermarket counts.
Yeah, count supermarket meals remaining minus minus. Make it one less than its current value. And additionally, we need to set what? Energy from food equals what? Main dot energy from what? What type of meal? Supermarket meal. Okay, Kurt sits ready for helping. Who raised their hand? This is kind of some heavy lifting. We're most of the way done with this decision pathway. Okay? And suppose we do have such a strong hankering for a convenience store meal that we decide to go get one. What do we need to do then? Well, we go shopping for that, right? So what I'm going to do, now watch this. This is going to be a link, ladies and gentlemen. This is going to be a link for this next bit. This is going to say, watch this. Are you ready? Okay, this is going to bring us back to some things from yesterday. This dot send go shopping. Now we're going to replace this later. Oh man. I'm thinking, should I do this now this way and replace it later? Let's just do it right. Go shopping for convenience store meals. I don't want to do that. There's going to be a typo, and then your model's going to break. And, well, then you won't cry, but it'll be bad. It'll be bad. So you don't want to do that. So don't do that. What would be a better way than typing this out and just making a mistake? Make an option list. Sorry, folks. Win one more for the Gipper here before lunch. Okay. Put one in for the Gipper. Let's add an option list. Let's do this right. Okay. Ready? Okay. So we're going to do. How do we add an option list to this for messages? New. Option list, okay. Messages. Remember this from yesterday? Ladies and gentlemen, AnyLogic is not this all-encompassing, ever-growing thing where you have to learn new, where you're drowned in information. It's actually this like a set of things you just keep on doing, keep on coming back to. And this is a pattern. You reuse these patterns lots of places. Yes, there are lots of pieces. Events, state charts, and different types of transitions, and parameters and variables, but there's not a huge number. And once you start exercising them, you'll find it's the same basic set of things. It's just a larger set than for system dynamics. Okay, the messages will be shop, shop at convenience store, shop at grocery store. Okay, those will be the messages. Okay, are we okay with that?
Supermarket?
Oh, sorry, sorry. Shop at supermarket. Thank you. Okay, are we okay with that? Okay, ladies and gentlemen, we just spared ourselves bugs. Okay. Okay. Okay, so let's go back to person. And now what do we send? Do we send this long, horrible thing? No. What are we going to send instead? Messages dot shop at convenience store. And you can even fill it out for you. Control space is your friend.
It's not working.
Works for me, but okay. Yeah, I know yesterday it wasn't working for messages either, so, for me. Okay, so I was able to fill it out, but maybe you can't. Shop at convenience store. You can go, another thing you could do is go here, select it, and do copy, and then you could go back and paste it in if you want to. Okay, so that's how we're going to do that, okay? Ladies and gentlemen, and oh, what do we have to label it? What is this going to be labeled? Shop at convenience store. Shop at convenience store, and this is going to be shop at convenience store. Okay. Okay, and I'll call it code shop at convenience store. Okay, great. Okay. Otherwise, we'll eat the supermarket meal. Okay, great. Do we have only supermarket meals available? Suppose, ladies and gentlemen, we have this case here. We do not have both convenience store and supermarket meals. We have no convenience store meals, and we have no grocery store meals, no supermarket meals. What are we going to do? Go shopping. We're going to go shop, okay? Mall of America. Okay. Okay, so this is going to be code, go shopping. Now, the label will be shop for food. Now, the question is going to be whither do we go is going to be the question. Okay? And what I'm going to do is to, in light of the time here, I'm going to write some code, and we're going to fill in the missing piece in a minute. Okay, this is going to say if, oh man, it's going to say if random true, probability of going for convenience food. Okay, we're going to actually have a function called that. I'll put this up on the big screen. If we do that, then we will do this dot send messages dot shop at convenience store, and we'll send it to ourselves. Otherwise, we will send ourselves the message, what? Can anyone tell me? What would this be? So we're flipping a coin according to some probability of going for a convenience store. If it's true, we'll go to the convenience store. Otherwise, we'll do what? Shop at supermarket. That's it. That, ladies and gentlemen, is it. Okay, but we still have to fill in this function. We still have to fill in that function. Okay, have we handled all cases here, ladies and gentlemen? Have we handled all cases?
No.
Which case haven't we handled? If we have both types of meals to choose from, what should we choose? So, I think we've handled basically, I'm going to zoom out here. We've handled almost all the cases. We've handled this one. So this one we have to go shopping for some sort of food and we flip a coin according to a function. Here we shop for a supermarket meal, otherwise a convenience store out of hankering, because we still have one grocery meal. Here we have convenience store meals. We eat the convenience store meal right now. And here, ladies and gentlemen, we have both types of meals. So what are we going to do? What are we going to do?
See which preference is higher?
Yeah, okay. Okay, so that's right. That's right. So we're going to do it according to our preferences, okay? So that's good. So what we're going to do is for this one, according to the preference, we will eat the appropriate food. So for the code for this one, well, let's call it choose food to eat, choose food to consume, to eat. Okay. Okay. Choose food to eat, and this is going to be code choose food to eat. And we're going to be choosing food from our larder. We have choice of both. Okay? So how are we going to do this? We're going to flip a coin. If random true, preference for convenience store meals, we'll flip that coin. Then we're going to eat a convenience store meal. Okay, now really I should have turned that into a function. I'm going to put it up like this. With that preference, we're going to eat a convenience store meal. How are we going to do that? Can anyone tell me? Anyone remember how to do that? How do we eat a convenience store meal?
Convenience store meal minus.
Yeah, count convenience store meals remaining minus, and then what? Energy from food equals what? Main dot energy from convenience store meal. Remember that?
Does it be minus 1 or just minus 1?
No, just minus subtracts 1 by default. So, in other words, this always subtracts 1. If you want to do like you can do minus equals 1, and this means subtract 1, which will have the same effect. Or you can do minus equals 2, subtract 2, or minus equals 10, subtract 10. But minus always means subtract 1. Okay. Eat a supermarket meal here, and I'll post this on the big screen in just a second. Count supermarket meals remaining minus, energy from food equals main dot energy from supermarket meal. Okay, I'm going to put this up on the big screen. This is the worst of the code. So, in short, ladies and gentlemen, we're going to flip a coin according to your preference. So you're looking at both types of meals. There's On the one hand, there's the chopped salad with some walnuts and arugula and iceberg lettuce and carrots and tomatoes. And on the other side are the screaming yellow zonkers. And you're going to choose between them according to your preference. So with a certain probability, you will consume the screaming yellow zonkers, and you will have a higher density of energy consumption. And otherwise, you'll eat the supermarket meal remaining and get your day's supply of fiber and good vitamins. Okay? No screaming yellow zonkers for you. Okay. And with this, we're going to break for lunch after this is entered. Okay?
I missed a bit of the code from the previous.
Yeah.
Okay, so I'll go through them. Okay? So we can go through them one by one. Are we ready for me to show the others? Or should I keep this up a bit longer? Okay. So do you understand? I mean, both of these are the same pattern. You eat one of the meals and you get the energy from it. You get the corresponding energy. Eat one of the meals, get the energy from it. This is just flip a coin with this probability. That's all that is. Does that make sense? Kurt, could you take down, AnyLogic should add an action chart item, which is just like do with probability. That would handle a lot of these cases. Do this, and you could have an if-else form of it or just by itself. Okay, are we ready for this? Okay, ladies and gentlemen, I'm going to go through these one by one. Okay? So top level, you decide whether you have both types of food. If you do have both types of food, you'll do this thing right here. And basically, the label will be choose food to eat. We okay with that? Choose food to eat. By contrast, if you don't have both types of foods, we first have to check which type do we have before we can decide what to eat. First of all, do we have only convenience store meals remaining? If all we have is the screaming yellow zonkers, in Australia it was the floaters, it was called, the floaties, something like that. That's an Adelaide treat, apparently. You then, if that's the case, then you eat the convenience store meals, and there might be a pie as well, like a shepherd's pie or something. Okay, so you eat the convenience store meal, so you get the energy from food for that, and you reduce the number of convenience store meals remaining. That's if we have convenience store meals remaining greater than 0. So if we do have convenience store meals only. Okay, now if we don't have convenience store meals remaining, we check, do we have supermarket meals remaining? Now, if we don't, we go shopping for food. And here we flip a coin according to a probability that we have yet to describe. And this will be based critically, this probability is based on a function that you will write after lunch. And that function is going to be based on the distance to the nearest grocery store and your preferences, not just one. It's going to be based on a distance. Okay? This is going for food. Go shopping. So we haven't filled this in yet, but we're going to call a function we write. And then, if it's true, we go shopping at convenience store, otherwise shopping at supermarket. I'll put that up there. Boom. And again, you're going to be writing this after lunch. Hopefully, you won't have consumed screaming yellow zonkers.
Well, we don't know if that's true. We got to run the model and see if it's good or bad.
Yeah, we'll see soon enough. Okay. So ladies and gentlemen, do you want me to keep this up a bit longer? A bit longer? So basically, we're saying, hey, go shop at a convenience store, go shop at a supermarket, go shop at a convenience store with this probability of going for convenience store food. Does that make sense? Okay. So this is just basically saying, hey, with this probability, shop at a convenience store, otherwise shop at a supermarket. Okay. So that's if we don't have any supermarket meals. If we do have a supermarket meal, the Nickean rule basically said, okay, do we so strongly convert convenience store meals that we go get one? And to determine this, we had a random true based on the preference for convenience store meals. If we have a strong preference for convenience store meals, we go and we shop at a convenience store. Here we just send a message to shop at a convenience store to ourselves. Otherwise, right here, we eat a supermarket meal remaining. After all, we have one left, we eat it. We have at least one left, we eat it. And, yeah, and those are all the cases. Are we okay with that?
Can you hop over to that second one to the right?
This one, or
Convenience store? Yeah.
eat the convenience store meal remain?
No, the one to shop at the convenience store if they really.
Oh, if they have the hankering? Yeah, it's right here.
Awesome, thanks.
Okay? Are we okay with that? Okay. So after lunch, we'll put into place the final jewels on the crown, which won't be long in coming. There's a little bit of logic to take into account not just the preference, but the distance to the nearest store. The idea is you might have a strong preference for a grocery store, but you live next door to a convenience store. So you'll sometimes go to the convenience store just because it's there, and get the screaming yellow zonkers. Not because you want them, but because they're what's available easily. Otherwise, you go to the more distant one. And by contrast, you might have a preference for a convenience store. The fact that the grocery store is so far means you're even less likely to go there. Okay? So we're going to put into place that function, this probability of going for convenience food, going shopping for convenience food. This one, this guy here. We're going to put in place that, and then we're going to have a state chart which takes them there, and we'll see them moving around, and we will see their girth changing over time per their diet. Okay? Okay, so that's all for now. Let's come back in an hour's time, and we'll finish up this example. Okay? Thank you very much.